Okay, if there are more questions, let's thank the speakers again.
So the next speaker is actually, the speaker himself is not there, but his advisor is there. So I'd just like to introduce Dr. Prasoon. Mr. Prasoon from IIRS, Dehradun. So he works broadly in the area of remote sensing, and his student was to make the presentation, but his student is not here. So he has a few things to share with us for about 10 minutes, or 5 to 10 minutes.
I shall not make you late for lunch. Okay, just can I start? Good afternoon, guys. My name is Prasoon Gupta. I work for this organization called Indian Institute of Remote Sensing. We are a unit of the Indian Space Research Organization, or ISRO as you know it. And we are primarily into research and training into a field called remote sensing and GIS. How many of you heard of this series? Oh, a lot of you. Very good. Nice. Thank you. So what I'm going to share with you is a very small project that a student from an unknown college in Ghaziabad came to me and to do. And thanks to his proficiency, he managed to do a project to visualize time series data. Can you go to the next tab? Before I go on to the project, Prabhu asked me to tell you about how Python is used for scientific computing in our domain. Let me tell you, there's a company called ESRI which makes a package which is used by most of the people who are using GIS. Once you say the term GIS, it is that specific package which comes into mind. And the biggest thing is that a package's acceptance to involve Python for customizing it for the, it's a big deal for the Python community. So going on to the project, what I, can you play this video? What our aim was to develop something like this, not the fly-through, but to visualize satellite data in order to visualize the change happening in it. So why would we require to see the change, not only to make a nice GIF out of it or see the animation happen, but there is a field called phenology, or some pronounce it as phenology, which studies the changes in natural phenomena, or could be man-made phenomena. For example, forest fires. You know, Australia faces, even America has a lot of forest area which happens to get into fire every summer season. And it is very important to understand how it spreads, what are the factors that start these fires and all that. First step is you should be able to visualize the change happening. You should be able to understand where it is starting. Does it start at the same place all the time? What are the factors affecting it? And so on and so forth. So I have these many examples. The entire Japanese coast has these fishing boats which light up in the night. And you can, if you have low light imagery from satellites, you can visualize the kind of fishing that's happening on Japanese coast. You can visualize changing in oil drilling patterns from the flares that they are emitting from time series data. The idea is to study time series data to visualize change that is happening. Now you come to satellites. You can imagine the Earth, and there are these small objects which are revolving the Earth, and they are starting from anywhere from 200 kilometers from the surface here up to 36,000 kilometers. I do not need to tell you all that. But the idea is that these satellites with all types of cameras working in all types of bandwidths take images continuously. So there are satellites from 200 to 36,000 kilometers. Some are taking at a resolution of less than 0.5 meters, yeah, theoretically they say in few years you would be able to read number plates, car number plates from satellites to large phenomena like cloud movements and so on and so forth. So the idea was how the satellite repeats, or when it can take an image of the same area again. But now with cameras which are movable, you may have heard of a camera or satellite sensor called Cartosat. They have cameras which can move on the satellite so that they can take images of areas which are required, for example, flood affected areas and so on and so forth. So the project was all about, if I have all this data, can I visualize it at the click of a button using, of course, Python. The problems, let's start with a problem that we needed to solve. The problem was primarily was data inhomogeneity. You have, as I said, data from all kinds of satellites. You have different radiometric resolutions. All of you know what is quantization and 6-bit to 25-bit data. You have images of different coverages. So you want to visualize floods in Chennai. You have data for the Chennai city, one satellite giving data for the Chennai city, one satellite giving you data for the entire south of India. So the extent, the coverages as we call it, is not the same. The brightness of these images also cause a problem because of the time of capture of the image. The factor that we call here is the solar zenith angle. Depending on how or when the sun is, when the image was captured, the length of the shadows or the phenomena appear differently. And of course, the electromagnetic region where the images were taken. The images are not always taken in visible range, as you may be accustomed to viewing on Google Earth and so on, but they are taken in all kinds of regions, near infrared, short infrared, thermal, and even microwave regions. The second problem that that propelled us to do this study was the target audience. The people who come to our institute to learn these technologies are mainly liberal arts students. Not all of them are Pythonistas to begin with, and most of them would have lost touch with mathematics and programming for a very long time before they come to our institute. So they wanted an interface which could visualize this kind of data at the click of a button. And final thing that propelled us to do it was the lack of packages which do it, or the complexity of packages which are currently available to perform such kind of a task. So to talk about the solution, we took a small part of the problem. We wanted to study change in vegetation. Now, imagine if you could take, let's imagine if we can take the image of an area every 15 days, I should be able to monitor crop growth. So the crop has been sown, it has greened, and then it will ripen, it will become brown, and then it will be cut again, and then the cycle will follow. However, if the same images are taken for an evergreen forest, this cycle of repetitivity will not be there. The greenness is constant. So the factor, the greenness that we are studying, is most nicely or best represented in this region called NIR, or near infrared. So we took 15-day interval images from a satellite called MODIS, which is provided by NASA, and for the Uttarakhand region. And we clipped it for the Uttarakhand region, and we just wanted to visualize how the snowline patterns, as you know, every year it snows in the upper reaches of Uttarakhand, and due to the snow, the vegetation does not appear on the images. So the snow line, the point till where the vegetation grows during the winters, is slowly receding. And what if we could visualize it from a satellite data? So the can we go to the next? So yeah, this is the GitHub page for the tool that we created. The tool, we call it as a satellite data visualizer. please feel free to fork it and change it. It's a very simple Python code, just has one program and a UI. So yeah, talking about the Python part of it, we used a simple package, a very popular package called Goodle, spelled as GDAL, which is used to read and write raster data sets. The raster is basically the satellite image. We used Pylab for the plotting purposes, and we used PyQt for making the GUI and other tools like datetime and so on for parsing and so on. So let's come back to the screenshot of this, the above one. Yeah, this was the simple interface when the user starts it. All he needs to do is point to a folder where the entire data set is kept. It could be 10 days of images, it could be 1,000 days of images, and in any known data format, DD, MM, YY, and whatever date format may be the name of the file. So the first option asks you to input a folder. Second option asks you to give a boundary for the area which you are interested in. So these boundaries come in this format called shape files. So you can just put the boundaries, and then you can just click on start and visualize the data set. The other options here are very important when to solve the problems that I listed in the beginning. There are options to stretch them, so you understand histograms and image stretching and all that. Image stretching is very important when you talk about time series data with different ranges of values in each of the data sets. So this tool allows you to stretch the data in different formats like min, max, standard deviation, percentile, and histogram equalization. With respect to satellite data, there is a important nagging concept called no data, or pixels which do not have values or missing values. There is an option to remove those no data values if you can specify them. And finally, you can change different color maps to display the data. If you can scroll down, we have this. I've given some screenshots of how different color maps were used to visualize the same data set over and over again. So yeah, this is about just a small brief about the tool that we developed. It's not a very big project, but it's just a start on how large amounts of data can be visualized. And from here, we can take it forward to doing actual statistical change detection, finding out how many cycles happen in a year, whether there is migration, whether there is change in cropping patterns, whether there are whether there is urban growth, anything. The possibilities are endless. You can start here. You can contact me. I did not give my email address anywhere. Yeah, so contact me, or you can go to our website, iars.gov.in, and if you're interested in this kind of work. Thank you. This is my email address, prasun@iars.gov. Thank you.
Do we have any questions?
How does it deal with the missing values in a time series?
How does it deal with, okay, the question is how does the tool deal with missing values in time series? Thank you for asking the question. In fact, that is the one point I missed out. So currently the tool supports files which are supported by the library Goodle or GDAL, and that is a pretty exhaustive list. The data set that the sample data set also kept on GitHub is in this format called TIFF files, which you may all be aware about. But these files are a specialized type of TIFF files called GeoTIFF files, which have additional auxiliary information along with it. The auxiliary information also includes what is the no data value in the current image. Generally, that information may not be available for user-generated data. If NASA is giving you the data, it may be there, but if somebody else has prepared or done some processing and given to you, the value may be absent. The tool gives you an option to write that no data value in case you know. For example, in most meteorological data, -999 is used as the no data value. So you can, or if you have more no data values like this, for example 0 or 255 and so on, you can just separate them by commas and write in that tool in a box provided to you, and it will ignore those values when visualizing the data. They will be represented as the background color. Thank you for asking the question.
Any more? Okay, we're going to have lunch now, and we'll be meeting back here at 2 promptly. We have a busy schedule, so please come back promptly. Thanks.